Okay, guys, so let's go over significant figures. Now, this is going to be going by the rules, okay? So if we're going to go by the rules, the first rule we're going to talk about is that all non-zero numbers are significant. So whether I have the number 1 or whether I have 123,456, each one of these digits will be significant. So if my example was the number 1, then I would just have one significant figure. It would be 1. Now, if I have this other number, the 123,456, this would be 1 sig fig, 2 sig figs, 3 sig figs, 4, 5, 6. So this would be 6 sig figs. If I had the number, let's say we had 0.215, okay, and we wanted to count the sig figs for this, again, we have all of these are non-zero digits, so each one would be significant. So it'd be 1 sig fig, 2 sig figs, 3 sig figs. So my answer would be 3. Now, I've always put SF after mine. It's just so that my students don't think it's a calculation. So that's just me counting my sig figs. So super easy first rule. So all non-zero numbers are significant. So the next rule is that leading zeros are never significant. So we're often going to see leading zeros with decimal places. So if I had 0, 1, 4, 2, okay, this 0 is not going to be significant because it is leading. It's in front of these non-zero digits, okay? So with this 0 not being significant, everything else, since they are non-zero digits, would be. So it's 1, 2, 3. So that's going to be 3 sig figs. Let's say if we had 0.00002, okay? Again, all of these digits all of these zeros are leading. And our rule right now says that leading zeros are never significant. So none of these will be significant. But this 2 will be. So this number is only going to have 1 sig fig. Okay? Let's say we had the number 0.0024671. Again, our last example on this, these zeros are not significant. Does not mean we can just drop them, okay, because they are placeholders, but it does mean that they're not going to count towards our significant figure count. So we're going to have 1, 2, 3, 4, 5 sig figs, okay? So let's look at our next rule. Our next rule says sandwiched zeros are always significant. So what I mean by that is let's say we have 2003. Okay? These zeros are sandwiched between 2 non-zero digits. That's what I mean by sandwiched. Okay, I don't mean this 0 sandwiched. It has to be sandwiched between non-zero digits, okay? It has to be sandwiched between non-zero digits, okay? So if we go back to our example, we have this one. This 2 is obviously significant because it is a non-zero digit. This 3 is obviously significant because it's a non-zero digit. And then our zeros will also be significant. So this is going to give us 4 sig figs. Okay, let's say we had the number 0.00202. Okay, so we're mixing it up a little bit. Please understand that these zeros are considered leading. Okay, and are leading zeros ever significant? No. So those zeros are not going to be significant. Okay. Now we do have another 0, and it is right here. And this 0 is sandwich. And again, sandwich zeros are always significant. So this one will count. So that's going to be 1, 2, 3 sig figs. Okay. If I had the number 2.0202, again, these zeros are sandwiched, and so they would be significant. So that would be 1, 2, 3, 4, 5. That's a 5. 5 sig figs. All right, so our next rule, and this is really where it kind of gets a little confusing, is that trailing zeros are only significant if there is a decimal. Okay, so let me show you what I mean by this. Okay, so if I had the number 2,000, okay, these zeros are trailing. They come after my non-zero digit, okay? And since there is a decimal present, these zeros are significant. So this number would have 1, 2, 3, 4 sig figs, okay? Now the slightly confusing part of that is, let's say if we had 2,000 without a decimal. Remember, this says it's only significant if there's a decimal. So if there is no decimal here, then these zeros that are trailing will not be significant. So in this bottom number 2,000, there is actually only 1 sig fig. Okay, so let's look at some problems. So let's say we had 0.020400. All right, so let's classify these guys. These guys up here are leading, and the leading zeros are never significant. Okay. This little guy right here, he is sandwiched. And sandwich zeros are significant. And we have these little guys down here. These are trailing. And these are only significant if there is a decimal present. So we do have a decimal present, so these would be significant. So this number is going to have 1, 2, 3, 4, 5 sig figs. Okay. Now, if I had, let's say, 2,145.300. Okay, I just want to point out that there is still a decimal present, and these guys, these zeros are considered trailing. So since they're trailing and there is a decimal present, these would be significant, which would give me 1, 2, 3, 4, 5, 6, 7 significant figures. Okay. And lastly, because here I'm soon I'm gonna run out of time, counting and conversion factors have an unlimited significant figures, which means that they're not gonna limit the amount that you're counting with. So let's do a practice problem. Let's say we're solving for the volume of this square. Let's say we have a mass of 250.2 grams, and we said we were solving for volume, and so we have a density of 2.35 grams per centimeters cubed. Okay, so remember in our density problem, okay, D equals M over V. So if I'm solving for volume, I'm going to cover that little guy up. And so my equation is going to be V equals M over D. So my M is 250.2 and my D is 2.35. Okay, I'm totally going to run out of room. But let's take a second. Let's look back up here and figure out our sig figs. So if we look at this number, 250.2, we know all the non-zero digits are significant, and this 0 is considered sandwiched. So since it is considered sandwiched, it would be significant. So that's going to give me 1, 2, 3, 4 significant figures. Okay? And if we look down at our density, I don't have any zeros in this number, so I know that all of these are significant. So this is going to give me 3 significant figures. Now remember, when you're multiplying and dividing, you're going to round to the least number of significant figures, meaning my answer is going to need to be rounded to 3 significant figures. So let's see. So I put 250.2 divided by 2.35. This gives me a really long number. So this is going to give me 100, oh, wrong color. 106.468. Okay, 106.468. So if we have 106.468, and we said we need to get down to 3 sig figs, how are we going to round it? So the question is, let's count to see where ideally our number would stop. So we want to start with our greatest place value because that's going to hold the most value of this numerically. So this is going to be 1 sig fig, 2 sig figs, 3 sig figs. So ideally we could just stop the number here. So my question is, if I were to drop all of these digits back here, would it affect my largest place value? Can I drop this 4, 6, and 8 without changing my place value of my 1? Yes, I can. So I can literally just drop those numbers. So I'm going to get 106. Now we were solving for volume, so it's going to be centimeters cubed. This, it does not matter. You can have a decimal. You don't have a decimal. The decimal only affects your sig figs if you have trailing zeros. Okay, let's look at if we had, let's say we had the number 24.564, and let's say I needed you to get to 2 sig figs. Oh, hold on, that makes it look like, I forgot what number it was. Okay, we'll just make up another number. 26.542. Okay, let's say if I asked you to get this down to 2 sig figs, okay? Please understand, if you needed to get this to 2 sig figs, you're gonna have 1, 2. So you're gonna want to stop the number here. You technically can drop all of this without changing the place value of my 2. But if my last digit dropped is 5 or greater, I must bump up the number that stays. So this is gonna become 27, okay? Let's say we had the number 4,257.23, and let's say we wanted this number to get to 3 sig figs, okay? So again, 1, 2, 3 sig figs. So ideally we could stop the number there. But this is a problem. I cannot drop this 7 without changing the place value of my 4. Okay, remember it was a thousands place value, and if I drop the 7, it becomes 400. Now I can drop everything after the decimal, so we're just gonna wipe that out. We need something to hold our place value and not affect our sig figs, and it's this magic number called 0. And as long as we use 0 and we get rid of that little decimal, this 0 will not affect our place value. Now this was a 7, so it's gonna bump up the 5 to a 6. So my answer is going to be 4,260, and as long as I don't have a decimal, that's 3 sig figs. All right, I hope this helps, guys. If you have any questions, shoot me an email. Have a good night.